Homework 14, question 5. And it's about a hiker was walking with constant velocity of 1.2 I minus 0.9 J meters per second. And of course we're after finding the speed of the hiker. Now this is straightforward again, and as you've seen in the previous question. Now they tell us in the question that I is the east vector and J is the north vector. So what's actually happening is the hiker's moving 1.2 to the east, and then of course because it's minus 0.9 going down like that. And of course we're after the speed of which this takes place. So also we want to use Pythagoras here. So what's going to happen is we're going to have V is square root of 1.2 squared plus well, you could put minus 0.9 squared. And that will give us 2.25. Of course, if we actually work this out, then that'll be 1.5 meters per second. That's your final answer. So, on to question 5, part B. We're told at noon at 12, H is at position vector 100J meters. So write down the position vector of H at time t seconds after noon. So what we could say, the position vector. Now he's originally at 100 J. Now we know from earlier that the hiker is travelling at 1.2 I minus 0.9 for each second. So imagine this is t seconds after noon. Well, this is just going to be plus t 1.2 I minus 0.9 J. That'll be meters. And that's your final answer. Okay, on to part C. We're given another hiker now, which is K, and K is at 9I plus 46J meters, and K is moving with a constant velocity of 0.75 I plus 1.8 J meters per second. There's going to be a couple of steps to this one, but first things first, we need to do what we've done in part B. Now part B, if I just kind of refer to it, just see what, we're given H at its original position, and then a constant velocity that we got there, and of course we have to write where the position be after t seconds. We're going to do the exact same here. So the original position was obviously 9I plus 46J, and then of course the constant velocity 0.75 I plus 1.8 J. Well, that's how much I'm going to do after each second. We got t seconds here, so we have t 0.7 I plus 1.8 J. That'll be meters. So that's like the first step done in part C. But what we're after is to show that H to K is 9 minus 0.45 T I plus 2.7 T minus 54 J meters. And of course we know from previous experience that H to K, you'd have to do RK minus RH. So just to kind of to see what's going on. We've got RK here, and part B we've got RH there. So we're going to have to take away that from RK. Now we've got to be really careful here, because we have got J's and we've got I's. We want to keep them separate, but of course we've got to be wary that we've got some T's here as well. So in terms of T, in terms of I, we've got 9I there, we haven't got any normal I's there, so we're just going to have 9I on its own effectively. So I put that in the bracket. And then we have a look at the I's here. Because we're taking away RH from RK, we're going to have 0.75 IT minus 1.2 I then t. So we do that in the calculator. What is 0.75 minus that? And that of course will give us minus 0.45. And of course we know that's t, and we can say that's all I, because it's got 9i from here. And then of course we got 0.45 ti from this one. And then the same with the j's. If we have a look at the j's, we've got 46 and we're going to be minusing 100. And of course 46 minus 100 will give us a minus 54. So if I write that here, wait, now it's going to be part of our j's. Now if we look at our j's here, we've got rk minus it. So we've got 1.8 jt minus 0.9 jt. So we've got 1.8 effectively plus 0.9, so that will give us 2.7 t minus 54j. And of course our units for that is meters. And that is your final answer there. Okay, part D. We are shown that the two hikers meet and find the position of vector of the point where they meet. Well, when they meet, that will mean that h to k will equal 0. So we obtained hk here. So obviously we will set our I component to 0 and set our j component to 0. So what we're going to do here is 9 minus 0.45t equals 0, and of course 2.7t minus 54 equals 0. So what we do here is 0.45t equals 9. So t will equal 9 over 0.45, and t will become 20. And likewise for that one, if you rearrange that one, that will also be t is equals 20. So we got our value for t, so it's up to you how you do this. We know that rk will equal rh because they're meeting at that point. So you can either plug this 20 into your equation for rh or your equation for rk. That's absolutely up to you. So if I plug into rh, we're going to have 100j plus 20 1.2i minus 0.9j. So that gives 100j plus 24i, and then 20 times minus 0.9 will give us minus 18j. So join that all together, and then we got 24i, we got 100 minus 18, which will give us 82. And that's your final answer there.